Hello everyone, we are going to start this MATLAB program for the time scaling. This is the program for the time scaling, and it is being denoted by your y of n is equal to x of kn, where k is the scale factor. If k is greater than 1, of course it has to be an integer. Then it is times downsampling, and also called decimation, also called compression. If k is less than 1, of course once k is less than 1, it has to be, once it is 1 by k, then it has to be an integer. So on that case it is interpolation or expansion or upsampling. So to start with, we always use this command clc for clearing this command window. Clear all, to clear all the variables that is temporarily stored in the workspace. Close all, to close all the previously open figure window. So these are the consolation tasks. Next is to start with any signal. Always it is important to get the first time index or the starting time index of the signal. So here this input will prompt the input to get the first time index or the first time index of the signal. Then next is the x to get the input sample values for the signal. Then capital N is to calculate the length of the signal, and from this number of samples, starting time index, we can calculate the ending time index or the last time index of the signal, which is n plus n1 minus 1. Now from n1 to n2 with a step of 1, it is the time scale. Subplot, to plot the signal, we need to if we would like to divide the figure window. So here we are going to have two figures, one for the two plots, one for the original signal and another one for the scaled plot. So divide the figure window into two parts. So this subplot will divide that. So first index is for the number of rows, second index is for the number of columns, third index is for the figure number or plot number. So 2 rows, 1 columns, first figure. And since it is discrete time signal, so instead of plot we are using stem. The first argument is for the x-axis value, second argument is for the y-axis value. Here my x-axis value is the time scale, so n, and y-axis value is the sample values x, and these are represents for the color red. You can put blue, black, B for blue, then G for grid, Y for yellow, like that. And this grid is to have the grid lines in the plot. And the title to give the title of the figure, this string within single quote, it will print as a title. And the argument you can pass through is the font size of this text. So I have given font size 15. Now the time scale. So to get the value of the scale factor k, we are using the same command again, enter the scaling factor. Now as I already mentioned, if k greater than 1, then it is compression. Of course remember this k has to be integer. So if k is greater than 1, that means the compression. So we have to compress the time scale first. So this is the compressed time scale. So it was n1 was the original time index. Since my scale factor which is greater than 1 is k, for example k is 2, so it is n1 by k, and since it is the left hand side, so it is sail and floor, both will make it round it off. So sail will round it up towards the positive integer infinity, floor will be rounded up towards the negative infinity. Okay, now two variables j and l is being initialized with 1 to assign the new values. So to the for loop here, this for loop will start from 1 to, because as I already in the previous classes also mentioned, that MATLAB does not understand the negative index or the zero index. It is always the positive index. So for I is equal to 1 for the number of samples in the signal. It may be capital N as well, or length of x or length of n. It will be same. Now the value at a value of the time index is which is divisible by the scale factor will be considered for the compressed signal. So that is why this command or rem is used. So this rem is nothing but this value will be divided by this value and remainder will be returned. For example, if you can see here rem, say for 5, 2, that means 5 divided by 2, remainder is 1, so it will return 1. So if that remainder is equal to 0, then only the value of x, the value of x at that index for which remainder is equal to 0 is assigned to y. Now j is 1, l is 1, so y of 1. Suppose the time scale has been started at -2. Here I am showing one example that would be better. Suppose my n1 is -2, then my x is equal to, suppose so these are my simple values. So n is nothing but your length of x. So it is, there are 10 samples. So what will be your n2? That is the ending time index. Ending time index is here, since it is -2, so it is 7. So how it is calculated? Capital N plus n1 minus 1, so it is 7. Now my time scale n is equal to n1 colon n2, and x is this. So at -2 it is 3, at -1 it is 4, at 0 it is 6, at 1 it is 3, at 2 it is 8, like that. Now suppose my k is equal to 2. If k is equal to 2, so this first, what will be my new time scale? Nn is, as you can see, compression means in between these two, this 4 will rejected, this 3 will rejected, 9 will rejected, 4 will rejected, 4 will rejected, 3 will rejected, 9 will rejected, 4 will rejected, this 6 will rejected. So what will be the new time scale? New time scale will be your -1 to 3. How? CEIL cell within bracket n1 divided by k, 2 floor n2 divided by k. So as you can see, -1 to 0. So what will be the values? This 3, as I said, the value will be 3. Then this 4 will be rejected, that is at 6. Then this 3 will be rejected, then it will be 8. Then 9 will be rejected, then it will be 6. Then this 4 will be rejected, then it will be 5. Then this 6 will be rejected, there is no more, so it is done. So you see, at -1 there will be 3, at 0 it will be 6, at 1 it will be 8, at 2 it will be 6, and at 3 it will be 5. So this is how we do compression. So the same thing, you see, say I is equal to 1, it will go up to length of n. So if we take this example, here this length of n will be 10, right? So it will go from 1 to 10. Now remainder ni comma k. So what is ni? N of 1. What is n of 1? Minus 2. Minus 2 divided by k. Is it equal to 0? Remainder? Yes. If it is yes, then y of j. What is j? J is 1. Y of 1 is equal to x of L. What is L? L is 1 is equal to x of 1. What is x of 1? It is 3. As you can see, the first one is 3. Then j becomes 2. Okay, j becomes j plus 1, 2. L becomes, this condition is satisfied, so j becomes 2, and out of this if L becomes 2, next time I is equal to 2. So I is equal to 2. Now remainder n of 2. So what is n of 2? If in this example n of 2 is minus 1. So n of 2 minus 1 comma k, remainder. Is it equal to 0? No. So that means this part is not executed. So but L becomes 3. Okay, L becomes 3. So next time I becomes 3. N of 3. So what is n of 3? N of 3 is 0. 0 divided by k. Yes, it is 0. So now y of 2, because it was not executed previously in the last steps, so now it is j is 2, but x of 3, because L is outside. X of 3, what is x of 3? X of 3 is 6. So x of 3 becomes y of 2. So you see x of 3 becomes y of 2, and so on and so forth it will go on. So finally for this example you will get this value here in the y, and this part is again the plotting of the compressed signal. Okay, now suppose k is less than 1. Suppose I am giving k is more 0.5. Let us see this. So again I am showing this n, this was my n, this was my x. Now suppose k is equal to 0.5. If k is equal to 0.5, I am considering now k is equal to 1 divided by k. As I mentioned, once it is 1 divided, it has to be an integer. So while giving the value for k, you should see that once it is 1 by k, it has to be an integer. Now 0.5, so it will be an integer 2. So what it will be? The time scale now will be double. I mean not since k is becomes 2 finally, so it will be double. So minus 4 to 14. So how it will be? The new time scale, suppose it is n1, nn is equal to n1 star k to n2 star k. So it is minus 4 to 14. And what will be the values? Values will in between there will be a 0. In between there will be a 0. So 30406030809080. So the value will be like this. Your 304060, then 30809060400506. So you see at minus 4 it will be 3, at minus 3 it will be 0, minus 2 it will be 4, and so on and so forth. At 14 it will be 6. So this will be your result. So how this thing is done? Suppose k is equal to 0.5 you have entered, so k equal to k by 1 by k, so it becomes 2. So this n time scale becomes n1 to k into k, n2 into k. Again 2 variables j and l is initialized. Now in this time I should be 1 for length of n and not length of n, because the new time scale has been changed. The procedure is again same. Remainder nni k, if it is equal to 0, then yj will be x of l. Now say I is equal to 1. I is equal to 1. So nn of I. What is nn of I? Minus 4. Divided by 2. Yes, it is equal to 0. So j is already 1. So y of 1 will be x of l. L is also 1. So x of 1. What is x of 1? 3. Then L becomes L plus 1 like this. Like this it was outside. Now here it has to be incremented inside. Why? Because we need to put 0 in between. Suppose this condition is not met, then y of j is equal to 0. We'll come to that. Now this part is executed, so this else will not execute. J becomes 2 now. Now it goes out of the loop, so it goes to I is equal to 2 now. Remainder nn2. What is nn2? Minus 3 divided by k. It is not divisible, it is not equal to 0, so this part will not execute. Else, if not execute, then y of j. So j becomes 2. So since y of 2 is 0, so this is 0, and so on and so forth, it will go on. So finally you'll get this value as a result, and ultimately this subplot. We are using the same subplot command here as is this. Why? Because either this part or this part will be executed, not simultaneously both. So that's all for the time scaling. Now we'll see the results. Let us run it. So I'm just executing it. Here you see enter the starting point of the signal. Let us put say minus 2. Then I am giving this the values that I was taken for example. Okay, this is the original signal. Now I am using the scale factor set 2. So as you can see here, this is the compress. So it was at minus 2 to 7. Now it is minus 1 to 3. In between these two, these get discarded. In between these two, these get discarded. So at minus 2 it is 3. At 0 it is 6. At 2 it is 8. Like that. Same values you can see here. And is this new time scale, and is this new values original values of x is this, and now y is this. So in between 3 and 6, 4 get removed, 6 and 8, 3 get removed, 8 and 6, 9 get removed, 6 and 5, 4 gets removed, like that. Now same program I am running again minus 2 to the same values, this one. Then now I am putting 0.5 as an expansion. So as you can see here, in between two successive samples, 1, 0 get interpolated. And the results you can see here. And is this for this original x is this, and now double minus 4 to third rotation, and y. So in between this 0 get interpolated. That's all.